Hi all, I am Divya Somakumar and in today's video we are going to make a model to predict whether a person has corona or not using the support vector machine's classification algorithm. Now let's begin by first importing our required libraries. Import numpy as np, import pandas as pd, import matplotlib.pyplot as plt, import cborn as sns, import warnings dot filter warnings we ignore. Now let's run all our libraries. So our libraries are successfully run over here. Now let's import our data set. This data set is about COVID-19. I have taken this data set from the Kaggle website. I will provide the link for the data set in the description below. Now let's write df is equals to pd dot read underscore csv. This is COVID data set. Now let's look at the head of our data set. Our data set looks something like this. We have breathing problem, we have fever, we have dry cough, sore throat, running nose, asthma, chronic lung disease, headache, heart disease, diabetes, fatigue, gastrointestinal, abroad travel, contact with COVID-19 patient, attended large gathering, family visited public exposed places, family working in public exposed places, wearing masks, sanitization from market, COVID-19. So now let's look at the info. df.info. So we have 5,434 entries and we have around 21 columns. Now, if you see, all the columns are in the object data type, which means that all our data is categorical in nature. So we have yes and no. We do not have any numerical value. Do you think we can fit a model when our data is categorical in nature? No, we will not be able to fit a model when our data is categorical in nature. We have to first convert it into numerical. How will we do that? There are two ways to do. One was one-hot encoding, the other one was label encoding. We have already studied about the one-hot encoding. If we use one-hot encoding, our number of columns will increase. Hence, we will not use one-hot encoding. We will use label encoding to encode all our columns. So, first we will import label encoding from sklearn library. From sklearn.preprocessing, import label encoder. We'll create an object of label encoder. Le is equals to label encoder. Now, let's run this. Now, we'll write a for loop because we cannot sit and change all the categorical data into numerical data. So, if we write a for loop, in one go, all the data will get converted into numerical data. Let's write the for loop. For call in df. What do we have to do? We have to do label encoding. Le is equals to label encoder. This is the object of label encoder. Now we have to fit this. Le dot fit underscore transform. What do we have to transform? We have to transform df call. Now, if we want the changes to be permanent, we'll have to recast it into our df call. df call. Now we have done our for loop. Now let's check the head. df.head. So we have 1 where there is yes and we have 0 where there is no. Now we have successfully converted all our categorical data into numerical data. Now we'll have to divide our data set into x and y. So our x is our independent variable. So all the columns leaving the COVID-19 column are our x variables. So how do we write it? X is equals to df dot iloc. I need all the rows, all the columns, but I do not need the last column. So we write -1 dot values because we want everything in the form of numpy arrays. Y is equals to df dot iloc. I need all the rows, but I only need one column, -1 dot values. Let's run this. Okay, we have successfully run this. Now we have to divide our data into training data and testing data. How do we do that? From sklearn dot model underscore selection, import train underscore test underscore split, xtrain, xtest, ytrain, ytest equals train underscore test underscore split. What do we have to do? X comma y test size, test underscore size, let's say 20% is equals to 0.2, random underscore state equals 0. Let's run this. So we have successfully divided our data into xtrain, xtest, ytrain and ytest. Now we have to fit the model. How do we do that? From sklearn dot svm support vector machine, import support vector classifier svc, because here we have a classification problem. We want to find out whether a person has corona or not. So let's create an object for svc. Let's say svm is equals to svc. Now let's fit this object svm dot fit. On what are we going to fit? We are going to fit the model on xtrain and ytrain. Now we predict ypred is equals to svm dot predict. We are predicting xtest. Our model is ready. Now we'll have to check for the accuracy of this model. How do we do that? From sklearn dot metrics, import accuracy underscore score, classification underscore report, confusion underscore matrix. Now first we will print our accuracy report. Print f accuracy accuracy underscore score what ytest and ypred. So we have to check the accuracy between ytest and ypred. Now let's run this. We get an accuracy of 0.97, that is 97% of the time the model correctly predicts that a person actually has corona. So our model has a good accuracy score. Now let's print out the confusion matrix. Print confusion underscore matrix y test y pred. Let's run this. So you have 179 true positive. That is people who actually have corona and is predicted to have corona. 13 false positive people who do not have corona are predicted to have corona. 11, that is people who have corona but are predicted to not have corona, and 884 true negative, that is people who actually do not have corona and who are predicted to not have corona. Now let's look at the classification report. Print classification underscore report by text by print. So our precision is 0.99. We have a high recall of 0.93 and 0.99. F1 score is also high, 0.94 and 0.99. So this was the model for predicting whether a person has corona or not. I hope this model is clear for one and all.